and gentlemen, my name is Mohau and welcome back to my channel. So today I'm going to be doing unit conversions, okay? So this I did yesterday, and I find that while I was doing it, I was like going through YouTube, going through Google, trying to figure out different types of formulas in order to derive them, to get the derived SI units of like physical quantities, specific physical quantities like pressure, energy. I was also like doing for force. I also did some for power, frequency, and then yeah, okay. Today I'm going to be focusing only on pressure, force, energy, power, and then frequency. Okay, that's what we're going to be doing for the day. Okay, ladies and gentlemen, just like I was saying, so I need to rectify something. I'm going to do pressure, I'm going to do force, I'm going to do energy, and I'm going to do power, but I'm not going to do frequency because I need to verify something over there. Okay, you can check it out, but I need to verify something over there. So going straight to pressure, we know that the defining equation for pressure is force multiplied by area, and we know the defining equation for force is mass multiplied by acceleration, and area is length multiplied by length, of which we are going to get length squared. Now in physics, length has we denote length in meters, meaning that if we have a meter and a meter multiplied by a meter, we're going to get m squared, which is, yes, the area. So in physics, we denote area as m squared, volume as m cubed. Okay, that's not the point. The point is over here. So as we know that mass multiplied by acceleration is equals to force, and length multiplied by length is equals to area, then we can try to derive this whole formula to simplify it even further. Now mass is already a base SI unit, but acceleration is not a base SI unit, and we have to derive acceleration in order for it to be a base SI unit. Now we know that acceleration is equal to the velocity over time, right? Therefore we still have like everything divided by length multiplied by length. Moving forward, we know that velocity is also not a base SI unit. So what we have to do is break velocity apart. We simplify velocity, and we know that velocity is displacement over time. And please note this, displacement is the same as length. Okay, so displacement is the same as length, meaning displacement is given by meter, m. So going forward, we still divide by length multiplied by length. Please do not try to cancel the displacement and the length. Do not try to do this. It was a simple mistake, okay? You do not do that. Instead, what you do is this. We know that mass is it has an SI unit of kilograms, displacement meter, time second, another time again second. So it's kilograms multiplied by meters divided by second, all divided by meter squared. Okay, m squared. Therefore, representing this in a simple linear form, we get that kilograms multiplied by m multiplied by second to the exponent of -2 multiplied by meter to the exponent of -2. This is what we get in a linear simplified form. Okay, so what you have to know is that this second is a denominator. Also, this is a denominator. So when we want to put them in the numerator, we have to put that negative sign to show that it is 1 over second, okay? Or m over second in this case, because it's m over second over second. Therefore, we want to put the second on the numerator. We just have to put the negative sign, and then we have like 2 seconds. That's the reason we have like negative 2. And then this meter squared is also in the denominator. If we want to put it on the numerator, we also do the same thing. We put it on the numerator, but we put the negative sign over here. Now this whole thing, this unit, is now referred to as a Pascal, as we know that pressure is calculated, has an SI unit of Pascal. So that is how you derive the SI unit of pressure from its defining equation. So this is the defining equation for pressure, and that is the SI unit over there for pressure. That is how it is derived. Okay, now we move to force. Now in the previous example, I did mention that force is the product of mass and acceleration of an object, right? Now we have mass as a base SI unit, so we don't have to do anything to it. But then we also have acceleration. Just like I said, acceleration is not a base SI unit, therefore we have to break it apart. And as we break acceleration apart, we get velocity divided by time. And velocity is still not a base SI unit, meaning we have to break it apart too. Breaking velocity apart, we get displacement divided by time, all over divided by time. Now we represent them in their SI units. Mass, kilograms, displacement, meter, time, second, so it's kilograms multiplied by meter divided by second. In a simplified linear form, we get kilogram multiplied by meter multiplied by second to the exponent of -2, because we took these 2 seconds and then we put them to the numerator, whereas they were at the denominator. Now putting them in the numerator, we have a negative exponent. Okay, now we are moving to energy. This is a mistake that I made again. I used a formula I used potential energy. You know, I was like trying it out, and that's the reason I decided to make this video, because energy is work. Okay, work is equals to force multiplied by displacement. That is the defining equation for energy. Okay, but in this case, this whole thing is incorrect. Okay, this is incorrect. Please do not look at this. Instead, we are going over here. Now we have work is equals to force multiplied by displacement. Okay, cool. Displacement is a base unit, is a base SI unit. Force is not. What we have to do, we have to break force apart. Breaking force apart, we get mass multiplied by acceleration multiplied by displacement. Therefore, acceleration is not a base SI unit. We also have to break it apart, velocity divided by time, and then that is how it is. Velocity is still not a base SI unit. We have to break it apart, displacement over time, all over time. Okay, now we represent them in SI units. Mass, kilograms, displacement, meter, time, second multiplied by displacement, it's a meter. Okay, now we have to like put it in a simplified linear form. Okay, putting all this in a simplified linear form, we have kilograms multiplied by meter, m squared multiplied by s to the exponent of -2, and this is referred as a joule, as we know that energy is calculated, energy has the SI unit joule. Okay, capital letter J, and work also has the SI unit joule, capital letter joule, or uppercase J. Not capital letter joule, but capital letter J, uppercase J, if you want to put it like that. Okay, and then afterwards we have power. power. Okay, now the defining equation for power is equal to W over change in time. This W is work. Okay, that W is work because the SI unit for power is watt, but please do not confuse this watt with work. This one is for work all over the change in time. Now, as we saw from the previous example, work is equals to force multiplied by displacement, and therefore this is what it is. Force multiplied by displacement is equal to work, and the change in time is second. Breaking this apart, mass multiplied by acceleration multiplied by displacement all over second. We break acceleration apart into velocity all over time, and then all this divided by second, and then we break velocity apart into displacement all over time, and then yes, still the same process. Like after breaking it apart, we represent using SI units: mass, kilograms, displacement, meter, time, second multiplied by displacement, meter, all over second. Second is a second. That's how it is. And then we are going to get this when we simplify this in a simple linear form. We get kilograms per meter squared multiplied by s to the exponent of -3. So over here I made a mistake, okay, but then using the laws of exponents I was able to see that okay, we have the same basis, meaning we can add the exponents. -2 plus -1 -3. Okay, that is how it is, and then we move on. Okay, kilograms meter squared second to the s to the exponent of -3. So that is all for now, because I also wanted to show you guys frequency, but I'm not certain about my workings. Okay, so please never mind this, just focus on this. Okay, so F is equals to 1 over T, and number of cycles divided by T is the amount of time. Okay, I'm not certain about this, but I know that frequency, the SI unit for frequency is hertz, and hertz is to the negative, it's s, okay, s to the exponent of -1. Okay, so that is the reason I am saying like I still need to check this. As you can see, I wrote check, but that's what I did for like yesterday, and then I also tried doing like, you know, unit conversions. I need to go through this again because hey, it was a little bit challenging, like not challenging, but then it was a little bit confusing, to be honest. I need to refer to my textbook, and then I'll come back to it and I'll show you guys. For now, that is the end of the video. You're welcome to the Royal House. My name is Mohau, and please do enjoy the content. Okay, peace out.